Hello, everyone. Welcome to All Aboard Reasoning with LLMs and Neo4j via MCP. This section is going to be presented by Michael Webb and Jonathan Giffard. Over to you.
Hey, folks. So I'm just going to do a bit of scene setting, and then Michael's going to take us to the good stuff. So let me start with that. I want you to imagine that you're trying to get to work. It was dead easy for me. I'm working from home right now, so it was an easy commute. But usually you'd be looking at trying to get to work, trying to find the quickest route. Nowadays, it's just pick your phone up, tap something into your navigation app, and it presents you with the route. In this case, we could be using the London Underground. And you don't really care about how, in this case, the London Underground works, only that it does. You just want to get to work or wherever you may be going. And what you're doing there really is asking a very human question, and you're getting an answer which is backed by data. And that data is connected in some way that allows you to do some route planning. And at this point, you're kind of wondering, is this a chat about optimizing your strategy for getting to work, or is it part of nodes? Well, let me segue onto that particular bit with the next slide. So when we think about connected data, we think about graphs, and we think about Neo4j, being the purveyor of the best world-leading graph technology. And yes, I am paid to say that. And Neo4j really excels at looking at storing your connected data. So examples could be supply chains, you could be looking at logistics, fraud, customer intelligence, social networks, and in our example, the London Underground. So it's really good at doing that. And if we look at AI and our large language models, they're really good at having conversations. And they're also really good at reasoning and explaining how they reached a conclusion. But they could be brilliant if they were connected to data, so you knew their conclusions were grounded in the real world and they weren't making stuff up, which people euphemistically describe as hallucinating. So what if we could get those two things to work together? And that's where MCP comes in, because that gives us a standard way of connecting your large language model, like Claude, Gemini, ChatGPT, Grok, or whatever you're using, with Neo4j and other connectivity options as well. So now, by having that connection to the real world, when I'm asking my large language model, it's using what's in my graph, my connected data, as a source of truth, and it bases its answer on that truth and explains how it got there. So now we've kind of gone beyond it's a commute. We can now explore many what if type scenarios. So if I want to get to work using the London Underground, what if one of the stations on that route is shut? Is there an alternative I can take? Can you give me more than one route? What if I started from a different station? So I can now evolve my immediate questions into more of a conversation and explore. And it's not just the London Underground. You could do that with your supply chain. You could ask, given my most popular product, can you show me potential bottlenecks in my supply chain? So now we've got real world data. We connected it to our agent via MCP. So let's talk about what Michael's going to do over the next remaining time we have together today. So on to the demo. Let's talk about the demo. We're going to use the London Underground. And that little drawing on the right you can see is the London Underground, but it's plotted by where a station is. So it's using the geographical locations of stations to show you what that looks like, as opposed to the diagram you normally see of the London Underground, which is more focused around the routes. And the reason we're going to use that is the London Underground is something which everybody can relate to. It's also a real system. It's not something we're just making up. It's got technical depth because there's a lot of complexity, as you can imagine, which goes into the London Underground network, making sure trains go where they should. And it allows us to do a great demo. But the other reason I quite like it is it has some great drawings and maps. They're very iconic. So let's go ahead now, move on to the demo bit, and we'll see how we can chat with our large language model to help us analyze and work with our connected data, which is sitting in Neo4j. And we'll be using the official MCP server, which we're currently developing. It'll be out real soon, and Michael will go ahead and drive that demo for us. Michael.
Yeah, thank you very much. I will show you the MCP server in action. So 1 second, I'll switch my screen. Okay, is this visible? I assume so. Okay, so we have a little mcp.json configuration file for VS Code, which I'm using to do this demonstration, but this would be different in another client like Claude or something like that. Okay, I'm not going to show you my environment variables, but just assume that there's some connection details to a Neo4j database in here. And the first thing to do is start up the server. On here we have a little output log, which shows the server is running, and it's discovered some tools being used by the agent to perform some operations, which you'll see in a moment. So let me just close this and make this a little bit bigger. And I have a bunch of questions. This is based off the London Underground data set, which is already loaded into our database. So let's just ask some questions. I have a Neo4j graph, the London Underground. Can you summarize what's in it for me? So what's in the graph? I'm using Claude Haiku 4.5. So we see, let me try that again. It looks like the server wasn't running. Let's try again. I think it was a permissions issue. Yeah, there you go. So we have a summary of the graph where we have 272 stations in total, a whole lot of routes and a lot of underground lines, and we see basically a summary of the data as well. Obviously, we can ask more specific questions, but what's interesting is we can see the cipher that's being used in these connections to MCP, and so you can maybe learn a bit more how about you might use cipher. Okay, let's have a look. Maybe we can ask a different question. I would like to ask it to plan the fastest route for my commute to work, with my home station being Baker Street Underground Station and my workstation being Southwark Underground Station. So I want to see a list of stations for the route. All right. Once again, we can review each of the steps it took. I'm just not going to do that, but we can. We can have a look at see if the answers as expected is from me. I expected Baker Street to Bond Street 2 minutes, and I'm just going to carry on with a few more questions. So I want to analyze the importance of stations on my commute. So we have a bit more graph data science type of question going here. So it says it's going to be using the between the centrality algorithm to find out the most central station on my route. And we can see it's running a list of available GDS procedures. It's making all the necessary things it needs to do this projection. And we have Baker Street as the most important station, which is correct. It's the highest importance in our entire network. And it obviously goes on to explore why that is, and very interesting. So what other analysis could be interesting with my London Underground graph for my commute? One might ask. Well, let's ask the LLM instead.
I think one of the beauties of this is if you're not a data scientist, the large language model helps you out with using functions to help with analyzing what's in your connected data, right?
Absolutely. Yeah. You don't need to be in the details to get value. So we can see different kinds of questions we can ask. I'm going to ask a bit more about the neighborhood of my data. So let's identify which neighborhood clusters my home and workstations belong to. Remember, I'm not redefining that. That's in the memory of the LLM now.
So by this, what we're really asking it is to look at how well connected those stations are. And these types of graphs data science algorithms are really useful for things like, imagine you've got a social network and you've got people who like coffee, and you want to know, well, are there clusters of people in my social network who like coffee? Because you might want to set up a coffee club, for example, which I know is a tenuous example. But it could be, imagine they're your customers you're selling to, and you're looking for clusters of customers who are buying something, or maybe they're not buying one of your most popular products. You want to sell them it. So you can look for these groupings in your graph. Yeah. And you don't, in this particular case, because we're using AI, we don't need to know the cipher. We don't need to know the algorithms in terms of the detail. We're just having that human interaction with it.
Exactly. So what if we did want to open a coffee shop, let's say?
And why not?
Near my
Everyone
home
likes
station?
coffee, right? Yeah.
Most people like coffee, I would say, as a coffee drinker.
Yeah, same here as well.
So I would like to open a coffee shop. Should it be near my home station or workstation to attract people? That's the question. I don't hope we don't take too long with this answer. It's meant to be lightning. Okay, here we go. So it says the recommendation, open near your workstation, Southwark. It's got large customer base, multiple prime locations, diverse customer segments, mixed usage patterns. I had another question, but I think we're running out of time. So I just want to really quickly show the repository where you can have a look and download this yourself today. Hopefully I'm not too slow.
So there's Mike's looking at bringing it up on screen. There's a couple of things which we've noticed AI is really good for when it comes to graphs. One of which refers to the question which Mike was going to ask to wrap up, which was, can you improve my graph schema for me? And it's really good at actually looking at the way you've put together your graph and using the context of what you've just been doing to say, well, actually, if you change your schema slightly, then it would be more efficient, or you'd be able to do certain things which may be you can't do right now. So for designing your graphs, improving them, AI is another great way of doing it.
I'll put this channel link in the chat. All right, thank you very much. Sorry we had so much to show.
Thank you.